In the beginning, God created the heavens and the earth. According to the Bible, God created our universe in 6 days. On the fourth day, God created our sun, our moon, and the other planets of our solar system. Then it says, He made the stars also. Is this true history? Is this how our universe came to be? According to secular scientists, the answer is no. Most secular astronomers believe that the heavenly bodies formed by gradual natural processes over billions of years. They say that this idea is scientifically sound, that it's based on solid scientific principles, that it matches all the evidence. But this isn't true. In the first video of this series, we looked at the planets and moons in our solar system. We looked at the secular model for the solar system's origin, known as the solar nebula model. We discovered that there's lots of evidence against this model. Each of the planets contradicts it in various ways. In fact, the model predicts that many of the planets in our solar system can't exist at all, but they exist nevertheless. Rather than supporting the secular model, our solar system is consistent with the biblical account of creation instead. But what about everything else we see in the heavens? The universe contains 100 to 200 billion galaxies. Each one contains about 100 billion stars on average. Can the secular model explain these objects? No, it can't. In this video, you'll discover how the universe proclaims the glory of its creator as we explore its stars and galaxies. I'm Spike Basaris, your host. In this video, we'll be talking about stars, galaxies, nebulae, and many other things. Before we do that, though, we should talk about what they are. We've all seen stars in the sky, but many people don't know much about them. A star is just a hot ball of gas out in space. Our sun is an example of a star, and it's the one that's closest to us. However, not all stars look like the sun. Stars come in an amazing variety of sizes and colors. We'll talk later about why that's important. Also, not all stars are single like the sun is. Some stars have companions, with both stars orbiting their common center of mass. These are called binary pairs. Other stars are found in multiple star systems, made up of 3, 4, or more stars. In this video, we'll also be discussing galaxies. A galaxy is a large collection of stars, along with some gas and dust. Galaxies range from having just a few million stars to over 1 trillion stars. The galaxy we live in is called the Milky Way. This is an artist's conception of what the Milky Way would look like from the outside. Since we live inside of it, on dark nights we see it as a band stretching across the sky. We estimate it has about 200 billion stars, including our sun. Galaxies also come in a wonderful variety of sizes and shapes. Here are 2 galaxies in some familiar parts of the sky. Close to the Big Dipper, or Plough, is a spiral galaxy known as M81. Spirals like this one can have beautiful, intricate structures. Other galaxies have structures that aren't as well defined. Here's an example that's close to the Crux, or the Southern Cross, where we see a cluster of galaxies, including a massive elliptical galaxy and some other ellipticals and spirals. Along with stars and galaxies, we see lots of other beautiful things in space. In this video, you'll see many photographs of nebulae, large clouds of gas and dust. Some of these are among the most beautiful objects in space. They play an important role in the discussion about where stars came from, as we'll see. Lastly, you'll hear me use the word evolution in this video. This might surprise you, because obviously this video is about astronomy, not biology. Well, as you can see by these textbook covers, secular astronomers often apply the word evolution to planets, stars, galaxies, and even the entire universe. In astronomy, the word is commonly used to describe how these objects supposedly formed and changed over time, all by themselves, with no creator being involved. In this video, I'm going to use the word in the same way. So where did the universe come from? Most evolutionary astronomers believe that the universe formed by itself about 13.7 billion years ago in an event called the Big Bang. Here's a timeline of what they believe. Supposedly, the universe started out as an extremely hot and dense point, which suddenly ballooned in size. Eventually, it expanded to the size it is today. According to this idea, The early universe had nothing in it except gas. Eventually, the gas started to clump together. Within the clumps, there were areas of higher density, and those areas started to contract under the influence of gravity. As the clouds contracted, the gas was compacted and it heated up. Eventually, the gas was squeezing in on itself so tightly that nuclear fusion ignited deep inside. This was the first star. Other stars also began to turn on in the early universe. As stars formed, they gathered into clusters and galaxies. Exactly how this happened is still controversial, but most secular astronomers would agree that stars merged into clusters, clusters merged into galaxies, and galaxies merged to become bigger galaxies. Somewhere between 7 and 9 billion years ago, our own Milky Way galaxy began to form. Then, about 4.6 billion years ago, our Sun formed when a cloud of gas and dust collapsed. The planets of our solar system formed from the same cloud, including the Earth that we live on today. So that's an overview of the secular model. In the previous volume of this series, we saw that this model can't explain how the planets of our solar system formed. In this volume, we're going to step farther back and look at earlier parts of the model. We're going to ask an important question. According to the secular model, should there be stars and galaxies in the universe today? The answer is no, there shouldn't be. Let's talk about why. If the Big Bang model were true, should we see stars in the sky today? The answer to this will probably surprise you, especially because there are frequent announcements about discoveries of star-forming regions in space, like this nebula. We're told that we see lots of places where stars are forming today. Evolutionists like to point to regions like this as support for their model, but that's a logical fallacy, a red herring. Whether or not stars are forming in the universe today, or whether they could form in the universe today, is not the question. The question is this: if the universe formed itself, as the Big Bang model says, without a creator being involved, would we see stars today? And the answer is no. Here's why. In the Big Bang model, stars are supposed to have formed from clouds of gas, as gravity squeezed the gas together. But there's a problem here. A cloud of gas in space will not collapse into stars on its own. It's true that gravity pulls the gas molecules together, but gravity is a relatively weak force, and it's much weaker than gas pressure, which forces the gas molecules apart. Here's an illustration I like to use. This is a can of compressed air. When I pull the trigger, it opens a passage from outside the can to inside the can. So what happens when the gas can travel freely? It comes out, because gas always disperses from areas of higher pressure into areas of lower pressure. When I give talks about this, I like to ask the audience, how much gas would you need inside the can to create such a strong gravitational force that when I pull the trigger, gas wouldn't come out of the can? Instead, all the air in the room would get sucked into the can, and we would all asphyxiate and die. People laugh because this idea is ridiculous, but that's the kind of concentration of gas you would need to form stars from a gas cloud in space. You can't maintain a cloud of gas at a higher pressure than its surroundings unless you keep it in a container of some kind. This can is a container, so the gas stays inside without dispersing. But there aren't any containers in space, so there's nothing that prevents gas clouds in space from dissipating. Not only that, there are other things that will prevent a gas cloud from collapsing into stars. As one evolutionist wrote, "We know the cloud wants to collapse under its own weight to make one or more stars. But rotation, as well as turbulent motion within the cloud, work against that fate. So too does the ordinary gas pressure you learned about in high school chemistry class. Galactic magnetic fields also fight collapse. They penetrate the cloud and latch onto any free-roaming charged particles contained therein, restricting the ways in which the cloud will respond to its self-gravity." But you might be wondering something by now. If stars are made of gas, and if gas clouds in space will disperse, then how can stars exist? It's because they're much denser and much smaller than the gas clouds we're talking about. Gravity is stronger at higher densities and smaller distances. Therefore, if there's enough gas in a small enough volume, gravity is strong enough to overcome gas pressure. That's why stars are stable, even though they're made of gas. But interstellar gas clouds are too large and too diffuse for gravity to overcome gas pressure. So they won't collapse and form stars. they'll disperse instead. Evolutionists know this is true, but they need to have stars form out of gas clouds in order for their model to work. So how do they explain this? Actually, they have several explanations. First, they suggest that compression can overcome gas pressure and allow stars to form. The compression would come from a supernova. Supernovae are tremendous explosions in space. For a short time, they can produce as much energy as an entire galaxy. They're incredibly violent. For example, the Crab Nebula is the remnant of a supernova that occurred in the year 1054. This supernova was so bright that it was visible during the daytime for more than 3 weeks. Supernovae are thought to trigger star formation when one explodes close to a gas cloud. This creates a shock front, which compresses the cloud, overcoming the gas pressure. Gravity then takes over and compresses the cloud further, and stars begin to form. The second explanation is cooling. When a supernova occurs, it might also inject dust grains and particles into the cloud, or the grains can get there from other ways. The dust cools down the cloud, which reduces gas pressure and again allows stars to form. A third possibility is collisions, where the gas cloud gets compressed when something else collides with it. This can occur when galaxies collide with each other, as you see in this example here. A fourth possible explanation comes from black holes. Some evolutionists suggest that black holes emit jets of high-speed material, which crash into gas clouds and trigger star formation. A final possibility is that radiation from a cluster of newborn stars can trigger star formation within nearby gas clouds. So evolutionists have several explanations for star formation today. But notice something important about these explanations. They all require stars to exist before more stars can be made. Supernovae occur when old stars explode. According to the Big Bang model, interstellar dust grains also come from existing stars. The model can't account for them otherwise. Black holes are thought to form when massive stars run out of fuel or have certain other things happen to them. And before galaxies can collide, they first have to exist, and they're made up of stars too. The same is true for radiation from newborn stars. This is a huge problem for the secular model. The Big Bang can't make any stars until stars already exist. It's like the classic riddle of the chicken and the egg. You need chickens to make eggs, and you need eggs to make chickens. The Big Bang model has this problem on a much larger scale, a universal scale. It can't make stars until stars were already made. Add up all these problems, and you see why evolutionists say things like this. The origin of stars represents one of the most fundamental unsolved problems of contemporary astrophysics. There are so many uncertainties in this picture that at present we do not really have a theory of star formation. If stars did not exist, it would be easy to prove that this is what we expect. Most of us are persuaded that stars form out of more diffuse material, which must, therefore, condense, contract, accrete, etc. Nevertheless, nearly all observations of pre-main sequence and protostars are dominated by outflowing stuff. Literally hundreds of ideas on how stars were formed have been advanced in past decades. However, we are still far from any real solution. We're starting from a shaky foundation. We don't understand how a single star forms, yet we want to understand how 10 billion stars form. If none of us knew in advance that stars exist, frontline research would offer plenty of convincing reasons for why stars could never form. Remember this the next time you admire the night sky. All the stars you see, and billions more that you don't see, all defy the evolutionary model just by existing. Now, some people will claim that what I just said isn't true. They'll say this problem has been solved because there were some announcements recently that claimed that it was. For example, here's a report about a computer simulation that supposedly showed how the very first star could form. And here's another. But here's what they aren't telling you. These simulations all require something called dark matter. And if you ask an evolutionist what dark matter is, they'll tell you they don't know. Many astronomers believe that there's a lot of stuff in the universe that we can't see. There's supposed to be a huge amount of it, 5 times as much as all the stars and galaxies and everything else that we do see in space. But if you ask where all this matter is, they'll tell you it's invisible. It emits no light. It emits no radio waves. It emits no X-rays or infrared radiation. It's unlike everything else we know, but it must exist, or else their models don't work. We'll talk more about dark matter in the next video in this series. For now, I just want to point out that in order to explain where the first stars came from, evolutionists have to invoke things that nobody has ever seen and that nobody has any idea what it is or how it works. As a cosmologist recently told the BBC, "We don't know what the dark matter is. We don't know what the first stars are. If we bring these two problems together, when we know more about one, then we can say something about the other." Well, that doesn't work. Being ignorant about two things at the same time doesn't teach you anything about either one. If we don't know what dark matter is, how it works, where it came from, whether or not it could even have been formed by the alleged Big Bang, how it behaves, whether or not it interacts with ordinary matter outside of gravity, or anything else, then how can we make it part of a scientific model? The only reason dark matter can supposedly rescue star formation for the evolutionists is because nobody knows what it is, or has any definitive evidence for how it might work. So evolutionists are putting it in their models and claiming it can do all sorts of wonderful things because nobody can prove that it can't do all these wonderful things. But that's not how science is supposed to work. And even then, scientists have realized that not even dark matter can rescue the Big Bang from all its problems. So evolutionists also believe in something called dark energy. Together, dark matter and dark energy must be about 96% of the universe, or the Big Bang model can't work. But neither dark matter nor dark energy has a solid basis in physics. As the director of the Canadian Institute for Theoretical Astrophysics said, "We know the total matter content of the universe. It's 4%. That's the stuff we recognize as matter. The rest is something we don't understand." There was an article in the New York Times that talked about this. It talked about how the Big Bang cosmology depends on dark matter and dark energy. The article asked, "What is dark energy anyway?" And then it said, "The difficulty in answering that question has led some cosmologists to ask an even deeper question. Does dark energy even exist? Or is it perhaps an inference too far?" Cosmologists have another saying they like to cite. You get to invoke the tooth fairy only once, meaning dark matter. But now we have to invoke the tooth fairy twice, meaning dark energy. So evolutionists make jokes about how their model doesn't work unless you invoke the tooth fairy. Meanwhile, the public schools are teaching our children that the Big Bang model is true. There's a serious problem here. We've seen that the evolutionary model can't make stars. Well, that's a huge problem, because without stars, the model can't make anything else either. So far in this video, we've seen many photos of galaxies. As I explained earlier, galaxies are giant groups of stars. Evolutionists think that galaxies started as small collections of stars, which then merged to form larger and larger collections until galaxies were formed. The problem with that explanation is that if you can't make stars, then you can't make galaxies either. According to the Big Bang, there shouldn't be 100 billion or so galaxies in the universe. And even if stars could somehow be formed, getting galaxies to form from the Big Bang would still be a tremendous problem. Evolutionary astronomers even admit this is true. It has always been difficult for astronomers to explain why stars are clumped into galaxies instead of being spread out more uniformly in space. There shouldn't be galaxies out there at all, and even if there are galaxies, they shouldn't be grouped together the way they are. The problem of explaining the existence of galaxies has proved to be one of the thorniest in cosmology. By all rights, they just shouldn't be there, yet there they sit. It's hard to convey the depth of frustration that this simple fact induces among scientists. The formation of galaxies and larger scale structure remains TMI-UPIMA, the most important unsolved problem in modern astrophysics. Nearly a century after the true nature of galaxies was established, their origin and evolution remain great unsolved problems of modern astrophysics. While we're talking about galaxies, there's an additional problem that's been getting worse lately. As technology improves, we're able to look farther out into the universe than ever before. The Big Bang model makes predictions about what we should be seeing out there, but the galaxies we're seeing aren't matching the Big Bang's predictions. We can now see galaxies that are so far away they can only be seen by using the world's most powerful telescopes. Evolutionists calculate that these galaxies are so far away that their light would have taken billions of years to get here. Therefore, they figured that when we see these distant galaxies, we're seeing them as they were billions of years ago. Now, this isn't necessarily true. There are other ways to interpret these observations. We'll talk more about this in a later volume of this video series. For now, just remember that this is how evolutionary astronomers interpret these galaxies, and that this is not the only possible interpretation. So evolutionists believe that when we see these faraway galaxies, we're seeing them as they were billions of years ago. In fact, evolutionists believe that as we look farther out, we'll see galaxies as they used to be, farther back in time. So as we look farther and farther out, we would see galaxies as they used to be, closer and closer to the Big Bang. Well, the Big Bang model makes predictions about what these things should look like. It turns out that some of these objects do look different in some interesting ways, but they aren't matching the Big Bang's predictions. Evolutionist astronomers had calculated that galaxies formed 8 to 11 billion years ago. That's because according to the secular model, it takes 3 to 6 billion years for galaxies to form. So, as we started to look farther out into the universe, evolutionists expected to start finding immature galaxies that were still forming. But that's not what has happened. As we've looked farther and farther out, we're discovering mature galaxies at farther and farther distances. This has been called the early mature galaxies problem. We're finding mature galaxies where the Big Bang model says there shouldn't be any. For example, in 2004, astronomers announced the discovery of 300 mature galaxies that are so far distant that evolutionists believe we're seeing them as they were just 3 to 6 billion years after the Big Bang. The problem is that the Big Bang model predicted that only a handful of galaxies could have formed in such a short time. One secular astronomer said, "We expected to find basically zero massive galaxies beyond about 9 billion years ago, because theoretical models predict that massive galaxies form last. Instead, we found highly developed galaxies that just shouldn't have been there, but are." Another astronomer commented, "It's not quite time for theorists to panic, but we're getting there." The mature galaxy problem got worse when astronomers studied an enormous galaxy cluster that was farther away than any other cluster seen before. This is a huge structure, with the equivalent of several thousand galaxies like our own Milky Way. According to the Big Bang interpretation, it's not quite 4 billion years old, but it contains reddish and elliptical galaxies that, according to the secular interpretation, are supposed to be ancient. As one report commented, the discovery of such a complex and mature structure so early in the history of the universe is highly surprising. Indeed, until recently, it would even have been deemed impossible. Another group announced they had observed a group of galaxies that existed only 2.5 billion years after the Big Bang. But contrary to secular expectations, they were not only massive, but also very old. The astronomers said, "We are really amazed. These are the earliest, oldest galaxies found to date. Their existence was not predicted by theory. We're detecting galaxies we never expected to find, having a wide range of properties we never expected to see." A separate discovery showed 4 massive galaxies that, according to the Big Bang, had already formed when the universe was just 2 billion years old. The preeminent scientific journal, Nature, wrote about the discoveries and admitted, "It is clear that even the best models can't fully explain the evolution of galaxies." Then the mature galaxy problem got worse again, with the discovery of 5 large galaxies that the Big Bang says shouldn't be there. According to the secular interpretation, we're seeing them as they were just 1.7 billion years after the Big Bang. The report in Science talked about evolutionary models for star formation and complained, "But this process was supposed to take billions of years." It quoted one of the astrophysicists on the team who said, "We have no idea why these galaxies grew so large so soon." Not only that, the Spitzer Space Telescope team has found galaxies which supposedly had already formed just 1 billion years after the Big Bang. Then in 2007, astronomers announced the discovery of galaxies which had already formed just 500 million years after the Big Bang, just 1/2 of 1 billion. The Big Bang model says stars were barely beginning to form this early, yet here are hundreds of billions of them already collected into galaxies. And the discoveries have continued. In 2008, one report said, "The presence of such fully evolved galaxies so early in the life of the cosmos is hard to explain and has been a major puzzle to astronomers studying how galaxies form and evolve." In 2009, Nature reported more discoveries and said this, "The findings could overturn existing models for the formation and evolution of galaxies. That was the reason for the surprise, that it disagrees so radically with what the predictions told us we should be seeing. The farther out we look, the more we see that the universe does not match the Big Bang model. Now, I hope I haven't confused you here by talking about these objects having formed millions or billions of years after the Big Bang. I don't believe the Big Bang model. In fact, the next volume in this video series will expose many problems with it. For now, I'm just pointing out that if you do believe in the Big Bang, and you interpret these galaxies using the Big Bang model, you have massive problems with them, and the problems are getting worse and worse as we make more discoveries. Although most evolutionary astronomers believe in the Big Bang, many are also admitting that the Big Bang has serious problems explaining what we see. For example, after reviewing the 5 competing theories of galaxy formation, 2 prominent astronomers said, "We would not give very high odds that any of these theories is a useful approximation of how galaxies were actually formed." Others have said, "How did the galaxies form? The encyclopedias and popular astronomical books are full of plausible tales of condensations from vortices, turbulent gas clouds, and the like. But the sad truth is that we do not know how the galaxies came into being." Despite the fact that we live in a galaxy, the Milky Way, and we live next to a star, our Sun, we still have a very poor idea of how galaxies form and evolve, and how stars form from primordial gas. A completely satisfactory theory of galaxy formation remains to be formulated. It is rather embarrassing that no one has explained their origins. Most astronomers and cosmologists freely admit that no satisfactory theory of galaxy formation has been formulated. In other words, a major feature of the universe is without explanation. There is something badly wrong with our standard picture of the origin of galaxies. So we should ask, how much can the evolutionary model explain anyway? In the previous video in this series, we saw that according to the most popular evolutionary model, the planets in our solar system shouldn't exist, but obviously they do. Now we see that the model also can't explain stars. This means our Sun shouldn't exist. Neither should the other stars in the Milky Way. Neither should the stars we see elsewhere. Neither should globular clusters, and neither should galaxies, or clusters of galaxies. And I've just listed the contents of the entire universe. The secular model fails to explain anything we see in space. The universe defies the evolutionary model just because it exists. On the other hand, the biblical account fits the universe very well. Now let me be clear here. I'm not saying we should accept the Bible because science supports it. We should acknowledge the Bible as our authority because it's the Word of God. But the Lord has graciously given us scriptures that describe His creation, so we can see that the Bible is consistent with the universe we live in. There are also some amazing implications when you view the heavens in light of Scripture. Let's talk about that now. In the beginning, God created the heavens and the earth. The Bible says that God created the heavens and the earth in 6 days. The sun, moon, stars, and everything else we see in the heavens were all created on day 4. Scripture says that God did this for several reasons, and the heavens fulfill His purposes in some remarkable ways. Let's talk about 3 of them: signs and seasons, the sustaining of life on earth, and the demonstration of God's glory as Creator. Genesis 1:14 says, "And God said, Let there be lights in the firmament of the heaven, to divide the day from the night, and let them be for signs, and for seasons, and for days, and years." The Bible says that the Lord created the sun, moon, and stars to mark out times, signs, and seasons for mankind. And indeed they do. For thousands of years, sailors used the sun and stars to tell time and navigate their ships. Farmers used the heavens to make decisions about their crops. For example, the ancient Egyptians knew when the Nile would flood just by watching for the star Sirius to reappear each year. Our fundamental measurements of time are based on the sun and moon. Our days are based on the Earth's rotation relative to the sun. Our months were originally based on the moon's orbit around the Earth. Our seasons change as the Earth moves around the sun, and each time the Earth completes an orbit around the sun, we call it 1 year. We can even use the heavens as a reliable clock. Once you know how to read the sky, it's possible to figure out the hour of the day or even the night. So the heavens fulfill their first purpose of signs and seasons very well. The second purpose of the celestial bodies is to sustain life